Hello everyone. So in this video we are going to solve the problem related to the Maclaurin series. So before proceeding to the problem, let us revise the formula of the Maclaurin series. So if we wish to expand the given function using Maclaurin's theorem, so we can expand the given function as f of x equals to f of a plus x dot f dash a plus x square upon 2 factorial dot f double dash a plus x cube upon 3 factorial dot f triple dash a plus and so on. Okay, dot dot dot. So the series will repeat like this, proceed like this. Okay, so we can see that the main thing we need to calculate to solve the problem of the Maclaurin series is that we need to find out the f of a, f dash a, f double dash a, f triple dash a, and f 4 dash a, and so on. Okay, so the difference between the Maclaurin series formula and the Taylor series formula is we do not subtract a from x like as in the Maclaurin series. Okay, we keep the value of a as 0 in the terms like where we get the x. Okay, so as we can see here, so here we have subtracted the a from x in every term, but we will not subtract a. We will keep just a at 0 in the Maclaurin series formula. That's only the difference. Okay, so let us proceed toward the Maclaurin series problem. So the question has asked us to find the Maclaurin series expansion for the function f of x equals to sin x at x equals to 0. So the given function is f of x equals to sin x. So according to the series formula, we need to find the f of a, f dash a, f double dash a, and so on. Okay, so we need to find the f of x as, so the f of x is sin x, and the first derivative of the sin x is cos x. Second derivative of sin x is as minus sin x. That means if you again do the derivative of the cos x, we will get the result as minus sin x. Third derivative of sin x is minus cos x, and the fourth derivative of the sin x is sin x. Okay, it means that if we do the derivative of minus cos x, we'll get, simply if we do the derivative of the cos x, we'll get minus sin x, and but we have minus in front of the cos x, so we keep the minus as here. So the minus minus becomes plus, and the fourth derivative of the sin x becomes as sin x. So substituting the value as x equals to 0 in the place of x, so we get f of 0 as equals to sin 0, which is equals to 0, f dash 0 equals to cos 0 equals to 1, f double dash 0 equals to minus sin 0 equals to 0, f triple dash 0 equals to minus cos 0 equals to minus 1, f 4 dash 0 equals to sin 0 equals to sin of 0 equals to 0. So by using Maclaurin's theorem, so we will use the Maclaurin's theorem. So now substituting the values obtained, so we will substitute the above obtained values in the following Maclaurin's theorem formula. So we get f of a as f of 0. Okay, just replace x, just compare x equals to 0 with x equals to a. Okay, so if we compare x equals to 0 with x equals to a, we get the value of a as 0. So f of a becomes 0. So likewise f dash a becomes 0, f double dash a becomes 0, f triple dash a becomes 0, and f 4 dash a becomes 0, plus dot dot dot, and the series will continue like this. Okay, so if we substitute the value of f of 0, we will get the 0. So in place of f of 0, we will write 0. F dash 0 is equals to 1, so we will write f dash 0 as 1. F double dash 0 is equals to 0, so we will write it as 0. F triple dash as minus 1, and so on. Okay, so if we resolve, so if we arrange this equation, we will get the result as sin of x equals to x minus x cube upon 3 factorial plus x raised to the power 5 upon 5 factorial plus dot dot dot, and so on. Because this first term is 0, and third term will also become 0, and likewise first, second, third, fourth, fifth term will also get 0. So the series will continue like this. Okay, so the required, which is the required expression for the sin x using Maclaurin series expansion is x minus x cube upon 3 factorial plus x raised to the power 5 upon 5 factorial plus dot 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 and so on, which is the required Maclaurin series expansion for the function sin x at x equals to 0. Okay, thank you.